Okay, so today we'll discuss an important topic, that is the motion of a charge moving in a magnetic field. So here in this case, the magnetic field is toward inside this board. So here, if suppose the magnetic field direction is in this direction, one charge is moving inside this magnetic field, then what will be the motion, how the particle will move, or how it will be move inside the magnetic field. So we will describe basically the two cases here. One is, if this is the magnetic field, if the particle is moving perpendicular to the magnetic field. Another is if it has some component along the direction of the magnetic field, suppose making some angle with the magnetic field, like in the second case. So our target is basically to find out what will be the radius of the motion of the particle or charge particle, and pitch. Second thing, we will calculate pitch. What is the pitch? Pitch means what will be the distance covered by the particle in one rotation. So two things basically we will calculate. The two conditions are different. So the first things, as we know that when a particle is inside a magnetic field, when a charge particle is inside a magnetic field, it experiences a force, and that force is Q V cross B. Okay, Q V cross B. If the velocity of the particle is perpendicular to the field, magnetic field, then it is Q B B sin theta. Perpendicular case, for perpendicular case, theta is 90 degree. That is your B is perpendicular to B. Okay. So in this case, sin 90 is 1. So your force will be Q B B. This much force will be experienced by the particle if it will move perpendicular to the field. So how will be its motion? Its motion will be circular. Let's see how. Because V cross B, if V is perpendicular, suppose this is B is perpendicular to this one. So according to right hand thumb rule, this is B, this is your B. So if I'll put right hand thumb rule, so it is inside, it is B and B is inside. So I'll keep my fingers in this way, my thumb directs to inside, inward. So this is your towards center, or it's called centripetal force. So as it is towards center, so the motion will be circular. So let's find out the equation. So we know that if any particle rotates or revolves in circular motion, then the centripetal force is mv square upon r. But here we calculated in this case the circular motion or the centripetal force, this F is QVB. So we can equate it, QVB. Now VB cancelled out, so it becomes R is equal to MV upon QB. The first one is derived. Now the important thing you notice here, that the numerator MV is the momentum. So what will be the radius of a particle moving inside the magnetic field, now more will be the momentum of the particle, larger will be the radius or larger will be the circle. Okay, so this is important note, you can say. Now our aim is the second one, what will be the pitch, or what is the second case? First let's understand. Second case is if, first case is if the velocity or the speed of the particle, velocity of the particle is perpendicular to the magnetic field. Second case is if it is not perpendicular, having some angle with the magnetic field, then obviously suppose this is your magnetic field, these are the B. If B is, this is B, it is moving in with some angle to B. So it will have two components. One will be along the direction of B, that will be B parallel. Another will be in the direction of perpendicular direction. So this will be your B perpendicular. Now see, in this case, second case also, B perpendicular will be the same as first case. So B perpendicular will be responsible for the circular motion of the particle. Now B parallel case, B and B are parallel, so angle is theta is 0, sin theta 0 means this force is 0, so the particle will not experience any external force on this one, on the parallel component of the particle. So whatever the V velocity will be, it will not experience any force due to B, due to the magnetic field. So what it will do, it will push forward, means due to B perpendicular it will circle, it will move in a circle. Due to B parallel it will go forward. So what will be the motion? Slightly like spring like motion, that is in terms we call it helical motion, means circle then slightly it will move like this, then this is called your helical motion. So now we will calculate the pitch. What is pitch? The pitch is in one rotation the distance traveled by the particle or the charge. So in one rotation how much it travels, let's calculate. You know that your V is equal to R omega, or from here you can say R is equal to V upon omega. From here we got R is equal to mv upon qb, so I can write here R is equal to mv upon qb. Now I can cancel bb, or I can write omega will be here, omega will be reverse qb upon m. See, the frequency, angular frequency of the particle, charged particle is independent of the velocity. Whatever the velocity may be, the angular frequency will not be affected, and these things we will be using in your discussion of cyclotron. This principle is used there. So now we find out that omega is qb upon m. Now what we'll do, we'll calculate the pitch. So pitch is the distance we know that it is velocity into time. So velocity, the forward motion is only due to the B parallel, velocity in parallel direction. So that will be, I can write P is equal to B parallel into T. So T I can write B parallel, T I can write 2 pi upon omega, 2 pi upon omega, and omega we got here this one. So I can write, it will go up 2 pi m, 2 pi m, omega is qb upon m, m will go up B parallel by qb. This is your pitch, 2 pi m v parallel by qb. So here the thing is that I can write here P is equal to 2 pi m v parallel upon qb. The important is the two things are important. One is this frequency is independent of velocity or your energy. Another is radius. More will be the momentum of the particle, more will be the radius, or larger is the circle. Then another two thing is if the velocity of particle, because we are finding out what is our aim, what is our goal of this discussion. The goal of the discussion is to find out the motion of a particle or how the particle will move inside a magnetic field. Suppose there is a charge particle moving, a magnetic field is there, it is moving inside a magnetic field. If it will perpendicular to the magnetic field, it will just move in a circle. If it is moving with some angle or it has some component along the direction of the magnetic field, then what will happen? It will move in a spiral, like helical motion. Okay, and in this helical motion, the pitch or the distance traveled by particle in one rotation we have calculated out, that is 2 pi m v parallel by qb. Okay, so this is very important question for grade 12 students. Okay, we will discuss other things in the next class, and we will be definitely solving numerical problems also. Okay, thank you.